Okay, here we go. Environmental quality, outcome 3, part 2. So we'll start off with NIMBY. There is no away in throwing. So NIMBY is a popular acronym that became part of the environmental movement. Sort of like there was a recognition there was a need for certain things, but people didn't want it affecting the property values of their home. So NIMBY is not in my backyard. And so the acronym NIMBY, not my backyard, is an expression that summarizes people's growing awareness of the problems associated with waste production and storage, but that they wouldn't want it affecting their property values. We make about 1,000 billion kilograms of, or if you want, 1 trillion kilograms of solid waste each year. Solid waste, very easy to notice. It's also the least mobile. So people said NIMBY to, they want to build a landfill near their place, and people said, no, not in my backyard. It will be noisy and smelly. There'll be gulls and other animals around. Sometimes the landfills light on fire. And so people said they didn't want that sort of thing in their backyard. Okay, so we're going to look at solid waste first, not blowing in the wind. We're going to look at gases first, blowing in the wind. We've already learned that sulfur oxide, nitrogen oxide, carbon dioxide go into the atmosphere, move around the world, and they fall back to the earth as acid precipitation. In the southern hemisphere, this is mostly due to volcanoes and forest fires. Up here in the north, though, this is a result of human activity, burning fossil fuels mostly. Aside from burning fossil fuels, we also have soot from coal combustion and dust from wind erosion accelerated by agriculture. Those are the most common forms of pollutant particles. In weaker concentrations, heavy metal oxides from the combustion process are present, and the prevailing winds cause these to concentrate at higher latitudes where they eventually wash out of the atmosphere by rain or snow. They used to have lead in gasoline. Now all gas is unleaded because it turns out the lead would cause problems. It would also bioaccumulate. It would affect nervous systems of organisms. It would affect the growth of plants. And they did not know about that at the time. And then I believe it was somewhere around 1975, they started reducing the amount of leaded gasoline cars being produced. And by the time I was in high school in 1986, they outright got rid of it. The Inuit people in the high Arctic have the highest PCBs, polychlorinated biphenyls, known to our planet. Now, PCBs are produced by industrial combustion and they bioaccumulate. Have a look. This is a global problem. You have a combined effect. You have biomagnification, so this stuff is moving through the food webs, but you'll also notice all wind and water eventually flows to the North Pole. And so this explains why the highest concentration of PCBs is way up in the north, even though they never actually use it, because there's really very few factories other than Santa's workshop in the north. Okay, so this highlights the fact that this is a global problem, not a local problem. Next environmental problem we'll look at is the ozone and CFCs. So there's a layer around the Earth called the ozone layer. It's there to protect us from radiation, right? And so we in the past had done some damage to it. Let me explain to you what we had done. So chlorofluorocarbons, CFCs, are pollutants that were used. They were used as an agent in making styrofoam, and they were also used as propellants in aerosol cans. Also, all fridges and air conditioners used to use this as coolant in them. Okay, cheap, easy to make, very, very simple. Didn't seem to affect any sort of wildlife. So once again, a nice, simple chemical. And then, it was cheap, non-toxic, stable. It seemed like the perfect chemical. Unfortunately, it was later found out that CFCs would go up into the sky and they would react and form chloride ions. Now, these chloride ions would break down the ozone, and then the ozone layer gets thin, allowing more radiation in. And of course, that causes problems, right? Because the ozone layer is a chemical that protects us from ultraviolet radiation coming from the sun. Without it, you get too much radiation. So we're seeing damage to cells, organisms that are going blind. It's creating cataracts. It's creating increased cancers as well. And the hole at the top of the world is as large as all of the United States. And in certain parts of this place where it's damaged, the levels are 80% lower than what it should be. Okay. Now, how do we fix this? Well, in 1997, there it is, telling you the ozone hole in the atmosphere of the Antarctic was larger than continental United States and 40% lower overall concentration compared to normal. Since then, everyone in the world agreed to stop the production of CFCs, and that has helped. The hole has stabilized, and last year we were finding reports that the hole is actually slowly, super slowly, but starting to repair itself. So any of the CFCs that were released back in like 1994, 1995 has slowly made its way up there. And I'm assuming now that it's all used up, it can actually start repairing itself. We can you smelt ozone before. Ozone is that when you run a drill for the first time, or you run a drill, you'll notice the smell. So that's actually ozone. Or after a lightning storm, you can smell that funny smell in the air. That is actually ozone. So how do we make ozone? You can run a huge amount of electricity through air, and it makes the oxygen O2 turn into O3. But it does it very slowly. So trying to fix the ozone layer by all of us going out and running our electric drills is not going to cut it. Okay, but it is slowly repairing itself without, and there's people researching how to fix the problem faster as well. Okay, let's go ahead and look at water pollution. Okay, surface water is water found in oceans, lakes, rivers, and glaciers. It's literally the water that's at the surface. Most countries have enacted legislation to prevent dumping of waste products into surface water. This legislation targets point source pollutants, especially, and they have greatly reduced the pollution entering our surface waters. Now, most surface water pollution, though, is caused by everyday life, like washing your clothes or washing your car or watering your lawn, and that runoff goes into our storm drains. We're required to remove phosphates and nitrates from detergents and fertilizer. They got rid of them so that it did not cause a problem, to reduce the amount of organic material and to destroy disease-causing bacteria and viruses. We're not allowed to walk our dogs by the reservoir anymore. We're supposed to clean up our animal waste, not just because it looks not pretty, but also because the bacteria in that will go off into our storm drains, into our water, contaminating our waterways as well. Farmers are trying to right now design their irrigation so that none of it can actually be washed off and go off into our surface water. So we are doing things to protect our surface water. One of the major things we did was we actually clean our wastewater before we put it back into into rivers or oceans. And there's 3 phases in water treatment. Primary treatment physically separates the large solids and suspended sediments. Secondary treatment, so once it comes out of here, all the big chunky stuff is gone. Secondary treatment removes much of the organic compounds by using bacteria to decompose it. That means they have to pump oxygen in as well, because otherwise the bacteria will run out of oxygen. The resulting sludge that comes from that can be removed and treated by chlorination or UV, and then sometimes they'll actually take this sludge and put it on farmer's field and turn it over, and then 2 years later, that acts as a great fertilizer. After secondary treatment, the water comes out clear and they chlorinate it to kill any bacteria, but it still has phosphates, nitrates, other heavy metal waste possibly in it. So they then put it into tertiary treatment. They could either percolate it through soil, or they could pass it through a trickling bed evaporator, or nowadays they tend to use lagoons, and the lagoon has plants in it, and as the plants grow, they use up the nitrates, phosphates. They also take out the heavy metal waste. Now, this water you would not drink it, but once this is all cleaned up, then it gets pumped back out into rivers or the ocean, where Mother Nature can finish with the cleanup process. So here's the water treatment primary treatment, which traps the big solids. Secondary treatment is over here, where they add oxygen and bacteria, and then the organic suspended material becomes heavy as sludge, comes down in here. You can see, you can take down here. You could compost this, or I suppose you could incinerate it. You could use it as a fertilizer as well. And then the water comes out here. It's clear, but it's still got bacteria in it, so they add some chlorine to disinfect it, and then they put it here in the lagoon or marsh in order to finish water treatment. Okay, now groundwater is different. Groundwater is the water that's underground. It filters through the rock and the soil. It moves really slowly, about 15 meters per year. Okay, groundwater tends to flow to rivers, but its rate of flow really depends on how permeable the rock is and how much space there is for them to move through it. So this water, because it's underground, is really clean, and because it goes through all the rock and soil, it's really well filtered. Might have a lot of minerals in it, but otherwise very clean. And now if you have water from a well at home, you're probably tapping into an aquifer, right? Because it moves so slowly, 15 meters per year, you would run out of water really quickly if you're tapping right into its flow. But there are these large pools of underground water, aquifers, okay? And this is clean water as long as it's not been contaminated, okay? However, if it does become contaminated from pesticides, herbicides, solvents used in agricultural industry, this can end up being concentrated in aquifers, and this is really nearly impossible to clean up. You would actually have to pump all the water out and then also find a way to clean whatever was left over behind there. And you know, and at that point in time, it's not really feasible to do. So how can we do this? The best way to protect our groundwater is to not contaminate it in the first place. So here's a house where they have a septic tank, so they would want to make sure that the septic tank doesn't leak. They have wells nearby, so they can check the water if anything is leaking out of it. Here's an injection well, you have to be really careful when you do injection wells because you could contaminate the groundwater. Agriculture spraying, you want to be careful with that. If you spray here and then it ends up going all the way down to the groundwater, it can contaminate it. Gas stations, that not only do they have the big metal tank, they also have a plastic layer inside, and we have all sorts of sensors to do that. We also do a manual check of them. And of course, then we also have wells nearby where we check to see that nothing is leaking from the gas station. Okay, so I remember when we had our gas station, there was 3 or 4 layers of protection to make sure that nothing came out. If there's abandoned wells, they need to be sealed off. You can't just put a piece of plywood on top, because liquids can come off and run down into the groundwater. Industrial waste, same idea, right? You don't want it to be able to make its way all the way down. Landfills had a problem in that they would build landfills and materials that decomposes. A leachate, that's a fancy word. You do need to know this word, leachate. The leachate would go down to groundwater and contaminate it. So now with modern landfill, they go ahead and they put a layer of clay underneath, and then they have this really thick plastic that has a clay in it. So if something punctures it, the pressure of it forces the clay to come up and seal it, and that way that can't go down. They also build all of them on a slight incline, and they have a pump at the bottom, and they pump the leachate, the liquid from decomposition. They pump it out and they take it to a wastewater treatment plant to be cleaned up before it goes back into our oceans. Okay, so there's your water treatment plant. Biodegradability and the environment. Okay, so biodegradable means that living things can break it down. So bio means life, and degradable means it can be broken down. Biodegradable substances are those organic compounds, remember they have carbon and hydrogen, that can be broken down by bacteria, fungus, and other simple organisms into carbon dioxide and water. Apple cores are biodegradable and then most plastic wrappers are not. They have started making some biodegradable plastic wrappers, but for the most part, these that are made from petroleum products are not biodegradable. There's also been these green products. Now, you got to be careful with green products, right? A green product doesn't have to be 100% biodegradable. In some cases, the right conditions must be present for materials to be biodegraded. Some synthetic fibers are not biodegradable, even though their original source was. And then, of course, some biodegradable wastes are actually hazardous, and you would not want them to biodegrade. And so here is a list of different materials and how long it takes to biodegrade. Like cotton, pretty quick, 1 to 5 months once you throw it onto the ground for it to be broken down. Aluminum cans, 180 to 100 years before they break down. That's why really important to recycle those. Your gym strip, usually made of nylon, 30 to 40 years. So by the time you hit my age, I know that's a long time, it would finally have broken down. And plastic 6-pack holder rings, 450 plus years. They do experiments with accelerated aging. In case you're wondering, how do they figure out how long it takes for these things to be broken down by living things? And then hazardous waste. Hazardous waste is any discarded material that contains substances that are poisonous, toxic, corrosive, flammable, or explosive. Okay, this just can't go into any old garbage can. Has to be a proper way of treating it. These should all have WMIS symbols on them. Many of these materials can be found in your home, about 12 to 40 liters. Here's a whole group of different substances. Sink cleaner, drain cleaner, floor wax cleaner, oven cleaner, silver polish, furniture polish. If it goes old, the landfills have special recycling places where you could take these, and then they're taken to be dealt with as hazardous waste. Bathroom area, tub and towel cleaner, disinfectant spray, nail polish remover, prescription medicines, hair dyes, cosmetics, toilet cleaners. None of that, when it goes old, should go down the drain. Once again, take it to be dropped off. From the garage or your storeroom, paints, thinners, glues, lawn and garden herbicides, ant traps, powders, degreasers, antifreeze, gasoline, motor oil, brake fluid, all of that stuff has special spots at the recycling depot. In fact, you guys have a spectacular one by UFA. They will take stuff that even in Calgary they won't take. Many of these chemicals are solvents. Remember, solute, solvent. Solute is what you dissolve, and solvent is what it dissolves in. So these are used mostly as dissolving other substances, but they're all organic solvents. So they have carbon and hydrogen in them. And of course, all organic solvents are actually hazardous. Okay, so those have to be properly disposed of. They cannot just simply be thrown in the garbage. Waste management, let's look at the 4 R's: reduce, reuse, recycle, recover. Garbage is any material for which we no longer have a use for. Old paper, food scraps, tin cans, glass bottles, used motor oil, tires. There are 4 R's that you need to know of. The first one is reduce. Now, this is a strange one. If the goods are not manufactured in the first place, then there's no waste and there's no cost and there's savings of energy. For example, if you buy in bulk, there's less packaging, right? And that is a good way to reduce. If you buy a car that gets better gas mileage, right? That is a way to reduce because you're not using as much gasoline in order to do that. The number one example they use is buying in bulk for reducing. Okay, so you should know an example of reduce. You should use an example of reuse. Reuse is where you take a material, use it again for another purpose. An empty bottle could be used as a bank. So it served the purpose of the beverage holder, and now it's a holder of coin. Recycle is where a material is broken down and remade into something new. We recycle plastic jugs, aluminum cans, paper, metal, glass. Recycling one aluminum can saves enough energy to run an old TV for 3 hours. Your new TVs are way more efficient, so it could probably run a new TV for up to 6 to 10 hours. Recycling paper uses 58% less water, makes 74% less air pollution than cutting trees to make paper. So here's the thing you have to be aware of. Yes, it's very important to recycle. It's also very important to buy something that's made of recycled goods. Otherwise, all you're doing is collecting a whole bunch of paper in one place, and it's never, if people aren't buying the recycled paper, it's not actually serving its purpose. And then recover is where waste material is removed from a landfill or garbage and used for another purpose. Okay, so for example, we recover garbage and then we burn it to make electricity. Old tires. There used to be a giant pile of old tires on the way to Edmonton. Eventually, they took those tires, started making mats and mulches, and so they were able to take something that was totally garbage and bring it back. So if Mr. Tierra sees an old tire sitting on the side of the road and he picks it up, I've just recovered something. I then go home and I tie it up to a tree and make a swing for the kids. I've just reused it. Okay, and then when and then when my kids are gone, I take that tire and I take it to Canadian Tire and I drop it off with them, and they will then recycle it. Okay, and of course you could argue because I made my own swing, I did reduction as well because I did not actually have to go out and buy a swing. Okay, so you can see you could do many things with reduce, reuse, recycle, and recover. Here's the landfill construction. So in designing a landfill, you want to make sure there's clay and tarp underneath, right? So the leachate can't go through. It's a sanitary landfill because we put daily 6-inch dirt on top of it. There is a pump to pump the liquid out. We don't want the liquid all sitting at the bottom of the landfill. We want to remove it and take it to the wastewater treatment plant. Okay, now this is a short-term solution. Making a hole, even though it's a secure hole, and dumping our garbage in, not really a good solution for dealing with it. This is, short-term. Eventually, we're going to figure out how to do this better. Does it create a NIMBY response? That is, people do not want landfills near their house due to the noise, traffic, and the mess that goes with it. Modern landfill sites have the following components to it. So clay or plastic liner prevents the leachate, the liquid that results from decomposition, to end up down in our groundwater. Every day we put 6 inches of earth cover on top, and that's to prevent things from blowing around. It's also to prevent scavengers from being able to get in and populate that area. They also put fences around these to prevent people and animals from getting in. Now, unfortunately, if you make a really good landfill, what you do is you make it so it doesn't leak. It also means that you make it so it doesn't leak. It also means that oxygen can't get down. And so if you have things decomposing without oxygen, it's called anaerobic decomposition. In the process, usually when you decompose, you make carbon dioxide and water. But in this case, you make carbon dioxide and methane gas. And methane is explosive. And so old landfills, when they were improperly designed, would light on fire or explode. And so now we have ways to capture the methane and either vent it off into the sky, which, by the way, is bad. That leads to global warming as well. Or we could collect it and burn it to make electricity. So we could actually do a reclaim thing here as well. City of Edmonton does that. After they cap it, they collect the methane gas and they burn it to make electricity. Now, once this is done, your landfill is finished, and you put dirt on top. You can actually put plants on it, not big trees, but brushes. You can build golf courses on top of it, baseball diamonds, because those aren't heavy. You just can't put any big buildings on it because then the buildings would sink as the garbage sifts. And then there's secure landfills. This is where we take our hazardous and toxic waste. So this has to be on a very, very solid bedrock base so that the land does not shift. We still have the same old clay. We still have the testing wells. We have compartments where we take our hazardous waste, put them in. When this is done, we'll put a cap on top. We'll put a topsoil over it. We'll fence it off. But we will not build anything on top of a hazardous, a secure landfill where there's hazardous waste. Why do we compartmentalize it? Because one day we'll be able to go back and recover these chemicals once we know a way to deal with them better than putting them in a really secure hole. And of course, they use the same clay liner, but it's overlaid with a layer of gravel, a grid of perforated drain pipes to collect any seepage, and a final thick plastic liner backed by soft padding. When full, this will be capped by clay, plastic, and soil. The wells are drilled outside of it to monitor any possible leakage from the site. And then the last thing we look at is bioremediation. This is where you can use living things to break down toxic chemical into simpler non-toxic ones. Okay, plants work well for this. They can absorb the toxic chemicals through their roots and store them in their leaves or maybe in the stem, and then they come along and they cut the plants and they remove the waste. Like fescue grass can remove selenium metal from contaminated soil. There's also some bacteria that can attack and break down these more persistent toxic chemicals, but they need extreme conditions. So what they have is these big tanks called bioreactors. So you take your contaminated soil or water, add the bacteria, give the proper conditions, and then you can clean up that material. And that is the end of this unit.